Hello guys, so this is question 2.51 and the statement here is that a box contains 500 envelopes, okay, of which 75 contains $100 in cash, 150 contains $25 cash and 275 contains $10 cash. Okay, an envelope may be purchased for $25. What is the sample space for the different amounts of money? Okay, so let me first solve the first part of this question, and that is the sample space for different amounts of money. So we can see here that which are the different amounts. So we have here the amount of 100, similarly the amount of 25, okay, and also the amount of $10. Okay, so how many envelopes are of $100? So these are basically 75. Okay, how many of the 25? So these are 150. Okay, and how many are of $10? These are 275. So these are the different amounts of the envelopes. Okay, so what is basically the sample space? So sample space is basically composed of all the amounts in dollars. So those would be the $10. Okay, similarly $25, and the last one here would be the $100. Let me also put dollar sign with it as well. So this is what, this is the sample space. Okay, we have to find out the what is the sample space for different amount of money and then assign probabilities to the sample points. Okay, so now we have to assign probabilities to different amounts. So let me assign probabilities. So it would be 75 divided by the total number of envelopes, which are 500. So this would be the probability of it. Here it would be 150 divided by the total amount, that is 500, and for it what it would be, so that would be 275 divided by the 500. Okay, so these are the probabilities associated with each of the envelopes. So it would be of $100, it would be of $25, and here it would be of $10. So these are different probabilities associated with them, and then find the probability that the first envelope purchased contains less than $100. Okay, so the first dollar will contain the less than $100, and it is only possible if we have purchased the dollars which are either $25 or the envelope contain the $10. Okay, so what it would be, we can either have the probability that the dollar is of $25, or it can be of the dollar which contains the $10. Okay, so let me put their probabilities, and the probability of $25 is 150 divided by 500 plus, and the probability of 10 is what, 275 divided by 500. Okay, so it would be 275 divided by 500, and ultimately adding them together, taking the LCM, what I will get here 500, 150 plus 275. Okay, so at the end I will get what, it will be uh, 425 divided by the 500. So that is basically the answer of it. You can simplify it as well by dividing it over the 5 or 25 or so on, but I'm not simplifying it because this is the answer. Similarly, these were the different probabilities which I have calculated, okay, previously. So these are those probabilities. Okay. So I hope the underlying concepts of this question is now clear to you guys. If you have any question, you can ask me in the comment box. Thank you so much. Hello guys, so this is question 2.52, and the statement of this question is, suppose that in a senior college class of 500 students, it is found that 210 smoke, 258 drink alcoholic beverages, 216 eat between meals, 122 smoke and drink alcoholic beverages, 83 eat between meals and drink alcoholic beverages, 97 smoke and eat between meals, and 52 engage in all three of these bad health practices. Okay, if a member of this senior class is selected at random, find the probability that the student. Okay, so now we are given three case studies in which we have to find the probabilities of each of these cases. But before doing or diving into the details of this, let me first write the data here, whatever is available with us. So the first thing is the total number of students. So we have the total number of students, which is represented by n subscript t. So these are basically 500. So we have 500 students. Similarly, it is found that 210 smokes. Okay, so the number of students with smoke is NS, and that is what, that is 210. 258 drink alcoholic beverages. So let me represent it with N subscript D, and that is 258. Okay, this is here. And similarly, 216 eat between meals, and let me write it and subscript E, and here this is what, this is 216. Okay, these are the different data samples or data information which are given to us. Similarly, 122 smoke and drink alcoholic beverages. So let me write it like 122 smoke and drink alcoholic beverages. So let me write it smoke, and let me write this intersection as the AND operator, and here ND, and this is what, 122. Okay, so this is the data here. Similarly, 83 eat between meals and drink alcoholic beverages. So NE, and eat alcoholic beverages, drink alcoholic beverages. So N of D, that is what, that is 83. Okay. And the last one here is what, 97 smoke and eat between meals. So that is smoke and eat between meals, and that is what, that is 97. So these are the 6 data points. And the last one here is that 52 engage in all three of these bad health practices. So 52 of it are smoke and drink and eat between meals. So that is basically 52. So these are the data samples which are given to us. Let me represent them with this one. Let me separate them out, and this one as well. Okay, so these are the given data points. Now what do we have to do? We have to find out what the first part A is. The part A of it is smokes but does not drink alcoholic beverages. Okay, so part A is we have to find the probability that person smoke, okay, but doesn't drink alcoholic beverages. Okay, so and doesn't drink. So let me represent it. Okay. So how to find it out? In order to do these type of questions, let me consider another type of the diagram, that is called a Venn diagram. Okay, so let me represent here this circle, which basically represent the number of persons which smoke. Okay, and similarly that is N of D, which represents the number of persons with drink. Okay, so here in between them we have this area, which basically shows me that the number of people which smoke and drink as well. Okay, so this is the area in between them which is common. Okay, so which area is this and which area is this? Let me represent them with the different colors. So this area is the area in which person smoke but doesn't drink. Okay, so this is the area. And what is this area? This is the area in which the person doesn't smoke but drinks. Okay, so that is basically the overall area. Okay. So what do I have to find out? I have to find out the probability of it, because that is what we have to find out, and that is the area we have to calculate it. Okay, so in order to calculate it, what do I have to do? I have to find out NS and ND complement. Okay, the area or the number of people who smoke but doesn't drink. Okay, so in order to find out, we can see here that how to find it out. We can see that all of this area is basically n of s, which is represented here by this n of s. So this is n of s, and from it I have to subtract this area. Okay, so this is the common area in between nd and s, so I have to subtract it. So therefore minus ns and D. Okay, so I have to subtract these areas. So let me write their value. So the NS is here, which is given 210. And do I know the value of NS and ND? Let me search. So that is also given here. So that is minus 120. Okay, so calculating it, what I will get? I will get here 88. Okay, so that is what, this is the number of people who smoke but doesn't drink. Okay, so in order to find the probability of it, what do I have to do? I have to find the number of people, okay, who smoke but doesn't drink divided by the total number of people. So now I know all of this. So that is 88, which I have calculated now, and this is 500. So this is now the answer of my question, which I wanted to find out. Okay, so that is the solution of the part A of my question, which I have done. But so in order to solve question B, what do I have to do? Let me remove all this. So removing it, what I will do? So now part B is, we have to find out what? We have to find the probability that the student eats between meal. Okay, so what do I have to do? I have to find out the student who eats between meals and drink alcoholic beverages, and okay, and is always represented by this intersection symbol, and drink alcoholic beverages. So this is D, and but doesn't smoke. So okay, so he doesn't smoke, which is represented by this complement. So we have to find out this area. Okay, so in order to do so, let me again use the Venn diagrams, in which we have here the number of students who eat in between the meals. Okay, similarly the number of students who drink. Okay, so this is what, this is the number of students who drink, and here we can see that this is the area in between them, which is what, this is the number of students who, with NE and who drinks as well. Okay, so this is the common area in between them. Similarly, in order to find the smoking area or the students who smoke, what do I have to do? Let me have here this as well. So these are the number of students who smoke, and the common area in between all of them is this one. Okay, so which area is this? So this area is the area which basically shows us the number of students who eats in between meals, and number of students who drink, and the number of students who smoke. Okay, so here this one is that area. Okay, so now in order to find the probability, what do I have to do? I have to find out the number of, the probability or the number of students who eat in between meals, who drinks but doesn't smoke. So by looking at all of this, we can very clearly see that this is the area which portrays the number of students who eat in between meals and who drinks but who doesn't smoke. Okay, so this one is the area. In order to find it out, what do I have to do? I have to calculate this area, or let me represent this with this red color. So I should have this area, which is what, this overall area is, which I have represented with this color, which was NE and ND. Okay, and from it I have to subtract this area, which is NE, ND and NS. So let me write it minus NE, ND and S. Do I know their values? If I know their values, I can very easily calculate it. So let me find that. Do I know the value of NE and ND? So yes, I know the value, and that is 83. Okay. So the 83 is given here. Do I know the value of NE, ND and NS? Yes, it is already given here, and that is 52. Okay. So subtracting them, what I will get? I will get here 31. Okay, so the number of the students which are here are basically this. So this is 31, which is represented by this yellow color. So now in order to find the probability of it, I have to find out the number of E and number of D and number of S complement divided by the total number of students. So let me write their values here. So writing their values, let me write them here. I have calculated this is 31 and divided by the total number of elements, which are 500. So this is what, this is the solution of part B, which is asked here. Okay, so that is the solution which I have told you that how to calculate it. So in part C, we have to find the student who neither smokes nor eats between meal. Okay, so this is part C, and we have to find the students who neither eat neither smokes in between meals. So before doing it, we have to find the students who either smokes or eats or smoke and eat, both of them. Okay, so for it I have to find out. So let me first say that I have to find out the probability of students who neither smokes or neither eat in between meals. Okay. So before it, I have to find out the probability of S union E, because this union is what it basically shows me that either it was present or both of them were present in the event set. Okay, so therefore this is what we have. Okay, so now in order to find it out, what I have to do, I have to find out the probability of S plus probability of E. Okay, so after it, minus probability of S intersection. Why is intersection E? So let me show you with this diagram. So if I have this E or S and the other one is here with this one. Okay, so the first was this one, which composed of all the areas. Now I have included this E as well, which is now when added with it, I can see that this area, let me represent it with this area, which is the common area, has been included in it twice. Okay, so now in order to find the union of it, what I have to do, I have to subtract from it this area once, because it has already been included. So therefore I have to subtract this area from it as well. Okay, so now let me write the values of them. So what are their values? So let me put them here. So P of S, what is this? This is, let me first remove it. So this is what P of S is. N of S divided by N of T plus P of E is N of E divided by N of T minus P of S intersection E is N of S and N of E divided by N of T. Okay. So now let me write their values. So N of S is how much? That is 210 divided by the 500 plus N of E is how much? That is 216 divided by 500. So do I know the value of NS and NE? So that is already given here, NS and NE, and that is 97 divided by 500. Okay, so once I will calculate it, I will get what, if you will add them together, find the LCMs, what you will get, here 329 divided by the 5. Okay, so that is what, that is here we have. So this one is here, and this is 329 divided by 5. So now in order to find the value of the person who neither smoke neither eat in between meals, what I have to do, I have to find here the probability of student who neither smoke neither eats in between meals. So what do I have to do in order to find it out? We have to find it by subtracting this probability of S and E. Okay, so now writing it 1 minus 329 divided by 500 here. Okay, what I will get at the end, finding it out, what I will get here, I will get here 171 divided by 500. Okay, so that is the solution of part C which we wanted to find out. Okay, so I hope you have understood the underlying concepts of the questions like this one, and I hope you have understood the steps which I have taken in this question. So I will see you with the similar type of questions in our upcoming video. See you soon. Welcome back, guys. This is question 2.53, and the statement of it is: the probability that an American industry will locate in Shanghai, China is 0.7. The probability that it will locate in Beijing, China is 0.4, and the probability that it will locate in either Shanghai or Beijing or both is 0.8. Okay, so let me write the given data first. So given data here is, we have this given data, and the given data here is, let me write the Shanghai with this S and Beijing with B. So the probability of Shanghai is what? That is 0.7. Okay. Probability of Beijing is how much? That is 0.4. Okay. So the probability that it will locate in either Shanghai or Beijing or in both is basically the union. Okay, why is it union? Because in union either Shanghai or Beijing or both can be present in the event sets. So therefore, what do I have to do? I have to write probability of S union B is how much? That is 0.8. Okay, so what is the probability that the industry will locate part A in both cities and in neither city? So let me solve part A here, and when it will have to be located in both cities, it will be probability of S and B, Shanghai and Beijing. So how to calculate? We know the very famous formula, and that is probability of S union B is probability of S plus probability of B minus probability of S intersection B. So now changing their positions, what I will get? I will get probability of S and B is probability of S plus probability of B minus probability of S union B. Writing their values, what I will get? 0.7 plus 0.4 minus 0.8. Okay, so adding them together, I will get here 0.3, which is probability of Shanghai and Beijing together. Okay, so that is the solution of part A here. Okay. So in neither city, what do I have to do? I have to calculate the probability that it is neither in Shanghai nor in Beijing. Okay, so it will be what? It will be 1 minus what when it will be in Shanghai or Beijing or any one of them. So I have to find the inverse of them. Okay, so in order to find the inverse of them, I have to calculate the complement of it. So that would be 1 minus probability of S union B. Okay, writing their values, that would be 1 minus 0.8, because 0.8 has been given here, and at the end the answer of it will be 0.2. Okay, so that is what? That is the solution of part B. Okay. So I hope you have understood the concept behind this type of questions, and I will see you with some more interesting questions in our upcoming video. See you soon. So this is question 2.54, and the statement of it is: from past experience, a stockbroker believes that under present economic conditions, A customer will invest in tax-free bonds with a probability of 0.6, will invest in mutual funds with a probability of 0.3, and will invest in both tax-free bonds and mutual funds with a probability of 0.5. At this time, find the probability that a customer will invest in either tax-free bonds or mutual funds, and B is in neither tax-free bonds nor mutual funds. Okay, so first of all, what do we have to do? We have to write the given data. Okay? So whatever the data is, we have to write it, and we have to comprehend the data which is available here. So the customer will have to invest in tax-free bonds. Okay, so let me write the tax-free bonds at T. Okay, so probability of tax-free bonds is, the probability of investing in tax-free bonds is 0.6. Okay, and similarly, when invest in mutual funds, so let me write it like M. Okay, represented with M, and that is 0.3. So the probability of the investment in mutual funds is 0.3, while in tax free is 0.6. Okay, similarly, and will invest in both tax free bonds and mutual funds with a probability of 0.15. Okay, so previously I have told you that the intersection here is used as an and sign, okay, in which what is expected that both of the condition will have to be satisfied. Okay, similarly, U is the union, which is used as an or, in which any one or both can be applied together. So this is the or condition. Okay, either one or second or both. Okay, in which it is important that both of the conditions should satisfy. Okay, so that is here. So now here there is, we can see that there we have and, so therefore we will have to write here what, here we will have probability of investing in tax free and mutual funds is how much, that is 0.15. Okay, so what do we have to do? We have to find different situations. So now here in either tax free bonds or mutual funds, so that is here. So we have to find the either tax free bonds or mutual funds. So again we can see that here we have the or condition. So for or we can see that we have to use the union. Okay, so what do I have to do? I have to find the probability of tax free or mutual funds. So we can have a formula, and that is the probability of T plus probability of M. Okay, so and after it minus probability of T intersection. Okay, all of this data is available. So the probability of T is 0.6, probability of M is 0.3, and probability of T and M is minus 0.1. Okay, so from it what I will get? I will get from it is 0.75. Okay, so that is what, that is the answer of part A. So this is the probability of T or M, and that is what we have here, the solution. Similarly, in part B, what do we have to find out? We have to find that he the the probability that a customer will invest in neither tax free bonds nor in mutual funds. Okay, so he will not invest in both of them. So that is what, that is we have to find the probability that he will neither invest in this T nor in M. So that would be what, that is T complement intersection M complement, and this is basically 1 minus probability of T union M, which is what, sorry, T union M, which is what, which is already given and which has already been calculated. So now we can see that this was 0.75, so now it would be 0.25, which is the answer of. So that's it for today, in which we have seen the applications of the intersection and union, and how to deploy them in the scenarios where we have to find one or the other condition or both of the conditions or neither of them. Okay, so that is the solution of our question, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.55, and the statement of it is, if each coded item in a catalog begins with 3 distinct letters followed by 4 distinct non-zero digits. Okay, so after it, what we have to do, we have to find the probability of randomly selecting one of these coded items with the first letter a vowel and the last digit even. Okay, so in these type of questions, what will be the strategy? So let me write here the solution. So what can be the strategy here if I want to find out the probability of x? Okay, so what do I have to find here? I have to find the number of combinations of x or in x divided by the total number of combinations or permutations. Okay, so here in this question we can see that we have a what we have to see that how many items do we have. So if each coded item in a catalog begins with 3 distinct letters. Okay, so let me represent this one with the green color, okay, and this one with the blue color, and let me begin it. So here I can see that this is the first one. So here we will have 3 distinct letters. Okay, so these are basically the letters, and these are what? These are the 4 non-zero digits. Okay, so when these are the 3 digits, so how many items or how many possible letters will I have here? So here I will have 26 letter. If one has been occupied here, I will have here 25, and here at this location I will have 20. Okay, so these are for what? These are for the letters. Similarly, now for the non-zero digits, I can see here that here when 1 has been removed, which is the 0th item, so I will have here 9 left. Okay, similarly, when 1 will occupy this space, so how many will be left? So here 8 will be left. Similarly, 0 is removed because 0 will not be included here. 2 of them are also removed, so 7 are left, and here we will have 6. Okay, so multiplying them, I will have all these which can be multiplied together, and these would be the total combinations which I can have here. Okay, so after it, we have to find the number of combinations of x, which is basically what the condition given here. So find the probability of randomly selecting one of these coded items with the first letter a vowel. Okay, we will have to have here a vowel. Okay, here we will have a vowel, and the last digit is even, so we will have here the even number. Okay, so let me use this one here. So here this one. Okay, again we will have here 3 letters and 4 digits here. Okay, so let me first write the items here. So how many possible number of letters here? So we can see that here we will have to select any of the vowel because it should be started with the vowel. So I can have here A, E, I, O, U. So I will have here 5 choices. Okay, similarly, when here one of the 5 choices has been occupied, how many will be left here? Here I will have 25 left because out of the 26, one letter has occupied this spot. Similarly, when 2 letters has occupied this space, so 24 will be left here. Okay, so these are for what? These are for the letters. Similarly, for the digits, I have previously told you guys that first of all you have to write the digit which has been given in the condition. So I have to concentrate over this location because this is what we have to get the even digits. Okay, so how many items would I have here? So I can have here 2, 4, 6 and 8. Okay, I cannot include 0 here because that is not included here, and I have to not use it here anywhere. So here I will have 4 choices. Okay, so one of the 4 choices when has been attained here. So how many will be left? So I will have here 8, because one is the zeros which has been removed and the second one is this one. So I will have here 8. Okay, similarly when one this spot is occupied, this is occupied, so 7 will be left here for this spot, and similarly when 3 has been occupied out of the 9, okay, so 6 will be here. Okay, so after it what I have to do, I have to multiply them together. Okay, so these are what? These are the combination I have to use. So here I can very easily see that these are the total number of combinations which are here, and these are the choices which I have to make. Okay, so I can see here that these are the ratios. So I have to make what? Here I will have a ratio of this blue with what? With this green. Okay, so let me write them here. So here the blue ones are what? 5 into 25 into 24, and then 8 into 7, 8 into 7 into 6 into 4. Okay, so these are the combinations we have here, and similarly the green ones here are 26 multiplied by 25 multiplied by 24 multiplied by 9, 8, 7 and 6. Okay, so these are the numbers. So let me use them here and cancel them out which are common. So these would be cancelled out, these would be cancelled out. Okay, this one here, this one here, and this one here. So let me write them the numbers. What are the numbers? So 5 multiplied by 4 is 20 divided by 26 multiplied by 9. Okay. So here we have these numbers. So when these will be cancelled out, I will get here 10 divided by 13 multiplied by 9. Okay, so these would be what? These would be 10 divided by 117. So that is what? That is the answer of my question which has asked me. So in this type of question, what do you have to do? You have to write the number of combinations according to the particular condition and the total number of combinations which are possible in the same scenario. So that is basically the type of the strategy which you can employ in any of the questions which are like these. Okay. So that's it for today. If you have any question, you can ask me in the comment box. Thank you. Hello guys, I hope all of you will be fine. So this is question 2.57, and the statement of this question is, if a letter is chosen at random from the English alphabet, find the probability, okay, that the letter A is a vowel exclusive of Y. Okay, so we are not including Y in the vowels, and that is already not included in the vowel as well. So what will be the strategy here? So let me first write the generic formula for finding the probability of the situations or the events like this one. So in order to find the probability of the events like these one, what do I have to do? I have to find the probability of, let's say, event X. Okay, so what would happen here? I have to write the number of items in X, okay, divided by the total number of items which are basically in the sample space. Okay, we can see that the total number of items basically are available in the sample space. So that's why I'm writing them here. So this is a formula which I'm going to use here. Okay, so as part A is concerned, so what do I have to do? This is a vowel, so the event will be what? Event. So let me call this event X, and this event basically consists of all the items which are A, E, I, O, U. Okay, and the total number of alphabets or letters in English are 26. Okay, and now these are what? These are 1, 2, 3, 4, 5. So in order to find the probability of X, what it would be? It would be the number of items in X, which are 5, okay, divided by the total number of items, which are basically the English alphabets. So these are 26, and that is what? That is the answer of part A. Okay, similarly in part B, we have to list somewhere, we have to find the probability of the letter that are listed somewhere ahead of the J. Okay, so here let me call this event Y. Okay, and the set, it is consist of basically what? All the numbers which are lying before J. So these would be A, B, C, D, E, F, G, H, and I. Okay, so after it we will have J. So this is what? This is event Y. So the number of items here are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the number of items here are 9. So now if I want to find the probability of Y, what it would be? Using the same formula which is here. So using this formula, writing the number of items in Y, which are 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, divided by the total number of items, which are again 26. Okay, so that is what? That is the solution of part B. Similarly, in part C, what do we have? So we have to find the probability of the letter that are listed somewhere after letter G. So let me have this event Z, and in order to write the set consisting of all the elements in Z, those would be? So those would be, it is G, so after them would be X, Y, and Z. Okay, so these are the number of items in this set. So now let me count them. So I will have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So now in order to find the probability of Z using the same formula which is here, and now this formula, let me underline this one as well. This is the formula, and writing it now here, what I will have, the probability of Z would be, the number of items here are 19 divided by, okay, so that is what? That is the solution of part C. Okay, so this is the solution of part C. This is of part B, and this is of part A. So that's it for today, in which we have seen that how to find out the probability of the events where we have a certain number of fixed elements in the sample space, and out of that sample space we have certain conditions to pick different numbers. Okay, so that is basically the outline or the underlying concepts for all the questions like this. Okay, so that's it for today, and I will see you with some more questions in our upcoming video. See you soon. Hello guys, so this is question 2.58. And the statement of this question is: a pair of a fair dice is tossed. Find the probability of getting a total of 8, B at most a total of 5. Okay, so that is basically a question. And in solving this question, what is the first step? In the first step, what do I have to do? I have to find the sample space. Okay, so the formula which I am going to use here, and that would be the same. If I want to find the probability of X, then I want to find out the number of items in X, okay, divided by the total number of items which are the items in the sample space. Okay, so this would be the formula which I'm going to use here, and let me underline it first. Okay, so this is what, this is the formula which I'm going to use here. For this formula, what do I have to have? I should have the number of the items in the sample space. So writing here the sample space we have here. So as the two dice are tossed, so therefore the sample space it has would be, it could be 1 1 in both dice. Okay, it could be 1 2. Okay, it could be 1 3, 1 4, 1 5, and 1 6. Okay, similarly here it could be 2 1, 2 2, 2 3, 2 4, 2 5 and 2 6. Okay, similarly here it could be 3 1, 3 2, up to what, up to here 3 6, and this 3 6 would go up to here 6 6, in which it would go from here to 6 1, and this one will be here, and also it would be like this one. Okay, so here it will be here. Okay, so that is what, these are basically the number of items in the sample space, and in order to find the number of the items in the sample space, what do I have to do? I have to count them all here. So by counting them all, what will I get? I will get here the number of items in the sample space, and these are 36. Okay, so these are what, these are the 36 number of items which I have here. So now the first part of this question is the total of 8. So in order to find the total of 8, what do I have to have here? I have to look for the items here which will give me 8. Okay, so here I can see that there is no one here in the first row which gives me 8. Here this is the only one which gives me 8. Similarly here I will have 3 5, here 4 4. Okay, and here 5 3, and then 6 2. Okay, so here for this, let me have here the event A, and the items here would be what I can have here 2 6. This is the first item. The second one will be 3 5, then 4 4. Okay, then 5 3. Okay, and the last one would be, let me write it here, that would be 6 2. So that is what, that is the event A, and the number of items we have here are 1 2 3 4 5. So what is this? Let me write here. So the number of items in A are how much? 1 2 3 4 5. So these are 5. Okay, using the same formula here, and this is A, so probability of event A is what? That would be the number of items in A, which are 5 divided by the total number of items, which are 36, and that this is what, this is the answer of A. So that is what we have here. Now in order to find the solution of part B, what do I have to do? I have to find out the number of items in this set which composed of all the elements which are mentioned here, and that is at most a total of 5. Okay, so what does it mean? It means that all the elements must be here which has the maximum number of the summation equal to 5, and lower number can also be counted here. So here what would be those numbers? So let me identify those here. So those would be 1 1 is here, 1 2 1 3 1 4 from the first one. The other one is 1 5, and this would be 6, which is greater than 5, so I'm not including it. Similarly here 2 1 2 2 2 3 2 4 is not included. Okay, similarly 3 1 3 2, and then 4 1. Okay, so those would be the number of items here. So let me write them here, and let me use this color for it, and that is B. So for B, the number of items would be, it will be 1 1 1 2 1 3 1 4. Okay, so this will be in the first row. So or let me, okay, so this would be in the first row. Similar in the second row, I will have 1 2 3 items, then 1 2 items, and the last one here. So how many would it be? So it would be 1 2 3 4 5 6 7 8 9 10. Okay, so the total number of items in set B are 10. Okay, so let me write the solution of it here. So the probability of B would be the 10 divided by the total number of items in the sample space, that is 36. Or simplifying it, what I will get? I will get here 5 divided by 18, and that is what, that is the solution of part B which I wanted to find out here. Okay, so that's it for today. in which we have seen the solution of the two parts and how to find the probability of different events which are the subset of any other sample space. So that's it for today, and I will see you soon. Hello guys, I hope all of you will be fine. So this is question 2.61, and the statement of it is, in a high school graduating class of 100 students, 54 students studied mathematics, okay, 69 studied history, and 35 studied both mathematics and history. Okay, so if one of these students selected at random, find the probability that. Okay, so after it we have some options. So before it, let me write the given data. So the given data we have here is, that is a given data. So in a given data, let me represent the total number of students as ST, and these are 100. Okay. Similarly, students who studied mathematics, let me represent them with SM, and these are 54. Okay. Similarly, students who studied history are S of H, and these are 69 in number. Okay, and 35 students both studied both mathematics and history. So I have to write studied both mathematics, and in order to represent, and I am going to write here this intersection symbol, and with it I am going to write this H as well. Okay, because they have studied both maths and history as well. So these are 35 in number. Okay, so after, what do I have to do? I have to find the student took mathematics or history, any one of them. Okay, so in order to do so, I'm going to write the solution of it here, and the solution of part A is, I have to find the probability that the student took mathematics or history. So either I have to write SM or SH. So as I have mentioned in my previous videos, that wherever this or comes, I have to use the union. So therefore it will be union, which will be here. So I have to find the probability of the student who have taken either mathematics or history, and I have also known that in order to find it, what will be the formula? The formula for it will be probability of SM plus the probability of SH minus the probability of SM and SH. Okay, so this is the formula which I have to find out. I have the numbers which are mentioned here, but I don't know the probabilities which I have to find out. So therefore, in order to find the probability of SM, what do I have to do? I have to write the number of students who have taken mathematics divided by the total number of students. So both are present here. So therefore, it would be 54 divided by 100. Okay, similarly the probability of S of H, and it would be what, the number of students who have taken the history divided by the total number of students, and similarly for both of them I have to write the probability of the students who have taken mathematics and history. So it would be the number of students who have taken these two subjects divided by the total number of students. So this is basically the calculate data. Let me put it here, and what I will get here, it will be what, it will be probability of SM, that is 54 divided by 100. Okay, similarly probability of SH, that is 69 divided by 100, and now minus P, SM and SH, that is basically 35 divided by 100. Okay, so taking their LCM and then finding the summations, what I will get here, I will get 8. So after it, what I will get, it will be 88 divided by 100. So that is what, that is the solution of part A. Okay, so we have found out the solution of part A. Similarly, for part B here, what do I have to do? We have to find the probability that the student did not take either of these subjects. Okay, they have neither take the mathematics nor this history. So in order to find the solution of it, I have to find the probability that he has neither taken this mathematics and nor history. So it will be what? It will be 1 minus probability of taking either mathematics or history or both of them. Okay, so this is what, this is a condition which corresponds with either any of the options or both of them, that is basically the union, and basically satisfies the conditions where both of the given conditions are basically true. Okay, so now we have already found out the value of this one here, so let me put it here. That would be 1 minus 88 divided by 100. So finding it, what I will get, I will get here 100 and 100 minus 88, so it will be 12 divided by. Okay, so that is what, that is basically the solution of part B, which I have found out here. Okay, so that is what we had to find out. Now in order to find the solution of part C, we have to find the probability that the student took history but not mathematics. Okay, this is basically a very interesting phenomena. So for it, let me remove the previous questions here. So now we have to find the probability that the student took history but not mathematics. So in order to do so, let me use a diagram which is called the Venn diagram. So in order to represent history, let me use the green color, and in order to represent the mathematics, let me use this color. Okay, so for mathematics, let me have this diagram. This is for what? This is for mathematics. And for history, let me have this diagram. This is for history. Okay, and the area which is in between them, this is what? This is mathematics and history. Okay, while this area is what? This is the area where student has taken mathematics but not history. Okay, and this is the area where student has not taken mathematics but history. Okay, so this is what we have a area. Now what do I have to find out? I have to find out the probability that the student has taken the history but not mathematics. So therefore the area we have to find out here is basically this one. Okay, so we have to find the probability of this area, and that would be what? That would be the total area of the history minus the area which is here in this blue. So therefore writing it here, what I will get, so the probability of not mathematics and history, that would be what? That would be the probability of history minus the probability of math and history. Okay, so I hope you have understood the point that from this overall area I have to remove this one which is common between these two areas. So now putting the values here, probability of history is how much? So the probability of history is 69 divided by 100, and m and h is 35 divided by 100. Okay, so let me calculate it, and it would be 169 minus 35, so that would be 34 divided by 100, or you can simplify it further as well. Okay, so that is basically the solution of part C, and we have seen the Venn diagram for it. This is what? This is basically the Venn diagram, and with the help of which we have represented or solved our question here. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. This is question 2.62, and the statement of it has: Dom's Pizza Company uses taste testing and statistical analysis of the data prior to marketing any new product. Consider a study involving three types of crust. So okay, so there are basically three types of crust, which are thin with garlic and oregano, and thin with bits of cheese. And Dom's is also studying three sauces: standard, a new sauce with more garlic, and new sauce with fresh basil. Okay, so given data here is that for the sauces, for the crusts, I have basically three choices, and for the sauces I also have three choices which are given here. So how many combination of crust and sauces are involved? So in solving it, in any combination, I have to write what either a one crust or either one sauce. So therefore, for the crust, how many choices will I have? This is crust, this is for sauces. For this one, I have three choices. For this point, I have three choices as well. So I have to multiply them together, and here I will get nine choices. Okay, so how is it possible? You can also consider it from here that with thin crust, you can either have standard new sauce and a new sauce with fresh basil. So three choices. Similarly, for the second crust, you cannot again have the three choices, and with the third crust you can also have the three ones. So 3 plus 3 plus 3 is 9, which is basically 3 by 3, and that is 9. Okay, so this is the solution of part A. Similarly, what is the probability that a judge will get a plain thin crust with the standard sauce for his first taste? Okay, so as we can see that each of the item here has the same probability of the occurrence, each is equiprobable. So therefore we have here in the sample space, how many items we have here? 9 items, and each has the same probability. So the probability of this B is what? This is what? 1 by 9, and this is B is what? This B is the plain thin crust with a standard sauce plus standard sauce. Okay, so that is basically the event B, and we have found out the probability of this, which is 1 by 1. Okay, so that's it for today, in which we have seen the solution of the questions like this one. If you have any question, you have asked me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is question 2.63. And the statement it has is, according to Consumer Digest, July and August 1996, the probable location of personal computers in the home is as follows. Okay, so these are basically some probable locations in a home, and the probability of the availability of the PC in adult bedrooms is 0.03, in child bedroom it is 0.15, and in other bedrooms it is 0.14. Okay, so these are for the bedrooms. For the office or den, this is 0.40, and for the other rooms this is 0.28. Okay, so what do we have to find? In part A, we have to find the probability that a PC in a bedroom. Okay, so now let me solve it. This is the solution, and what do I have to do? I have to find, this is part A, and in part A I have to find the probability that a PC in the bedroom. Okay, so we have to find this one. So in order to find the PC in a bedroom, we have here 1, 2, 3 options for the bedroom, and let me call this one as the probability of the availability of PC in adult bedroom. Okay, this is in child bedroom, and this is what? In others bedroom. Okay, so these are for the bedrooms, and here we have these probabilities. And what do I have to do? I have to find the probability that the PC would be in adult's bedroom, or in child's bedroom, or in others bedroom. Okay, so here the formula for it will remain the same, but here you have to keep in your mind that in these formulas what will happen here. Here in any situation, A intersection C will be 0, probability of C intersection others office is others bedroom is 0, and probability that others and adults is also 0. Why is it? Because a single PC cannot be simultaneously at the two locations. It will either be in one location or in the other location, but it cannot be available in the both locations simultaneously. Okay, so that's why I am taking all these values equal to 0. So let me use them as well. So this is what we have. So if I have this, so what do I have to do? I can very easily see that it will be the probability that it is in adult's room plus the probability that it is in child room plus the probability that's in other rooms, or I have previously shown you guys that this probability of A is PA plus P subscript C plus P subscript O. Okay, so putting their values, what I will get? I will get here 0.03 plus 0.15 plus 0. Okay, so adding them, what I will get here, adding them, I will get 0.15, 0.14, that is 0.29, and 0.03, that would be 0.32. Okay, so that is the answer of part A. Similarly, what is the probability that it is not in a bedroom? So how to find it out? Let me write here this B. So the probability that it is not in a bedroom is equal to 1 minus the probability that PC in the bedroom. Okay, so that's it. We have this formula. Now, do I know the value of it? Yes, I have previously found it out in part A. So let me put it here, and I will get here 1 minus 0.32, and ultimately I will get what? It would be 0.68. That is basically the solution of part B. Okay. Similarly, for part C, we have to suppose a household is selected at random from the households with a PC. Okay, in what room would you expect to find a PC? Okay, so we have the overall data, which is basically given in the form of this table, and these are all the probabilities of the availability of a PC in certain rooms. So if I have to pick a house at random from the different houses having a PC, so I can expect here that the higher probability of the availability of PC here is 0.40, and that is in the office or den. Okay, so it is highly probable that I will find that PC in the office or in den. Okay, so that is basically the solution of what? This is basically the solution of part C. Okay, so that's it for today, in which I have studied the applications of the data, that how to find out the availability of different items in different rooms. So I hope you have understood the underlying concepts. See you soon. Hello guys, so this is question 2.65, and the statement of this question is: consider the situation of exercise 2.64, which we have previously solved. So let A be the event that the component fails a particular test, and B be the event that the component displays strain but does not actually fail. Okay, so these are the two events. First is A, second one is B, and let me write the data here as well. So this is the given data. Okay, so as I will read it, I am also going to write it as well. So A is what? A is the event that the component fails. Okay, so component fails, and B the event that the component displays strain but doesn't actually fail. So B is what? Display strain but doesn't fail. Okay, so let me use this one here as well. Event A occurs with the probability 0.20, and let me write here as well, the probability of A is what? That is 0.20. Okay, and event B occurs with the probability 0.35. Okay, so probability of B is 0.35. Okay, so these are the two events, and the given are their probabilities. Let me underline their probabilities. So these are the probabilities given to the events A and B. So what do I have to do? I have to find that what is the probability that the component doesn't fail the test. Okay, so let me write the solution here, and this is the solution of part A. And what do I have to do? I have to find the probability that the component does not fail. Okay, so I have to find out the probability, and it can be what? It can be 1 minus probability of the event that the component fails. Okay, which is what? Which is here event A, and the probability of it is already given. So let me put the probability it has, and that is 0.20, and 1 minus it is what? That would be 0.80. Okay, so that is what? That is the answer of part A of my question. Similarly, in part B, what is the probability that the component works perfectly well? Okay, so it neither displays strain nor fails the test. Okay, so these are the two things. It doesn't have to illustrate any of the two conditions. Okay, so in solving part B, what do I have to do? I have to find the probability that it neither displays strain. So strain is not available, and nor what? Fails the test. Okay, fail is also not available, and it would be what? In this I have to write the probability that if strain, okay, or failure, or any one of them would occur. Okay, so how to find it out? We have here, let me take it. So we have here this one, and how can we find it out? Let me write it here, and by writing it here, what I can have here, the probability of strain or failure is what? It will be the probability of strain with S. Okay, so let me represent strain with S plus probability of the failure. Okay, both of them are given here, and these are the event A and event B. Strain is the event B. So let me write their values here. So it will be the probability of B plus the probability of A, okay, which is the failure here, and strain is here. So let me write their values. It would be what? 0.35 plus 0.20, and ultimately I will get 0.55. Okay, so this is the value of it. So let me take this value and put it here back. So it would be 1 minus 0.55, and ultimately I will get what? This would be 0.45, which is the answer of the part B. Okay, so that is the answer of part B, which I have calculated. Okay, so now in order to find the solution of part C, what is the probability that the component either fails or shows strain in the test? So what is this? This is the same thing which I have found out here, and this is this one, okay, which I have calculated here, and this is what? This is the part C, and I have found out the probability of it as well, and that is the solution of part C as well, in which I have found out that the probability of failure or strain. So I have simply added their probabilities, and at the end I have found it out. Okay, so if any one of them or both of them can be occurred, is represented by this union, or if I don't want to find any one of them, what do I have to do? I have to find the intersection of the complements of the both events. So that's it for today, in which I have solved three parts of the question 2.65. If you have any question, you can ask me in the comment box. Thank you so much. Welcome back, guys. This is question 2.66. And the statement it has is factory workers are constantly encouraged to practice zero tolerance when it comes to accidents in factories. Accidents can occur because the working environment or conditions themselves are unsafe. Okay, so either the working environment or conditions are unsafe. On the other hand, accidents can also occur due to carelessness or so-called human error. So there are basically the two causes of the accidents. One are the unsafe conditions, while the other one are the human error. Okay, so these are the two main factors which has been found out by the data available in the industry or in the factories. So in addition, the workers shift 7 a.m. to 3 p.m. day shift, 3 p.m. to 11 p.m. evening shift, or 11 p.m. to 7 a.m. graveyard shift may be a factor. There are also some factors which are the time shifts, which has been divided into 3 shifts. During the last year, 300 accidents have occurred. The percentage of the accidents for the condition combinations are as follows. So this is the data of the what this is the data of the accidents in which I have listed the shifts, also the unsafe conditions, and also the human errors as well. If an accident report is selected randomly from the 300 reports, so I have to find out what is the probability that the accident occur on the graveyard shift. So I have to find out the probability that the accident has occurred in the graveyard shift. So in order to solve it, let me solve it here. This is the solution, and in order to find the solution of part A, what do I have to do? I have to find the solution of graveyard, and in graveyard shift I may have either unsafe condition or human error as well. So the probability of it, let me write it event A. So the probability of event A would be what? It would be the 2% and 30%, which in probability is basically 0.02. Okay, and 30% is 0.30, and I have to add them together because this graveyard is composed of this graveyard shift can have accidents due to unsafe condition or human error as well. So therefore the probability of it is 0.32, and that is the solution of part A. Similarly, now moving towards the part B, what do I have to do? What is the probability that the accident occurred due to human error? Okay, so human error can be the event in which I have to find the probability of the event. Okay, so here the human error can occur due to all these percentages which are mentioned here, and this is, let me call it event B. Okay, and this would be what? This is all the column which can be either day shift, in evening shift, or in graveyard shift, in which I have human error percentages given here. So therefore, in order to write them in the form of the probabilities, what I have to do, 32% is 0.32 probability, plus 25% is 0.25, and also this 30% is 0.30. Okay, so this is what we have, and finding it out here, this would be 0.87, which is the solution or answer of part B. Okay, similarly in part C, what is the probability that the accident occurred due to unsafe conditions? Similarly, now the unsafe conditions, this is the column which composed of all the percentages of the unsafe conditions which may occur in the day shift, evening shift, or in the graveyard shift as well. So I have to add them together. Let me call it event C. So event C would be what? 5% is 0.05, plus 6% here is 0.06, and the last one here is 2%, which is 0.02. Okay, so let me add them together and I will get here 0.13, and that is the answer of part C. Okay, the last one here is, what is the probability that the accident occur on either the evening or the graveyard shift? Okay, so evening, here I have to find out what. Let me have this event D. So probability of event D is what? That would be the probability that the event will occur, the accident will occur either on the evening. So let me write it evening or graveyard shift. Okay, so let me EUG. Okay, so or we can also find it out. These are the two conditions with which we have to find out the probabilities. Okay, so these are the two, or we can also find it out from all of these conditions by what? We can also find it out by 1 minus probability that the accident will occur in the day shift. Okay, so it will be probability that it will be in the day. Okay, so what is the probability of the accident in the day? In day, it can be either due to unsafe condition or due to human error. So it will be 1 minus probability of the unsafe, okay, or probability of the human error, okay, which is now 1 minus probability of unsafe condition in day is 5%, which is 0.05, and also the human error is 32%, so that is 0.32. Okay, so let me find it out, and I will here get 0.37. Okay, so let me take it here, and let me write it here as well, and 1 minus 0.37 would be 0.63. Okay, so that is what, that is the solution of part D. So that's it for today, in which we have solved question 2.66 by using different scenarios which are mentioned here, and this is the data which I had to analyze, and on the basis of different results I have to find the solution of the different points which are asked. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. So I hope all of you will be fine. This is question 2.67, and the statement here is that consider the situation of example 2.32. Okay, so the example here is 2.32 on page 58. So what is that example? Let me have it here. So this is the example 2.32. The probabilities that an automobile mechanic will serve 3, 4, 5, 6, 7, or 8 or more cars on any given workday are respectively 0.12, 0.19, 0.28, 0.24, 0.10, and 0.07. Okay, so let me first write them here. So I have the number of cars here and their respective probabilities here. What? So let me write them here. So I can have here 3, 4, 5, 6, 7, 8 or more. Okay, so I have different cars here. For the 3 I have 0.12, for 4 I have 0.19. Okay, I have 0.28 for 5, for 6 I have 0.24, 0.24. Okay, for 7 I have 0.10, 0.10, and for 8 or more I have 0.07, 0.07. Okay, so by adding them all, you will see that all of them will be added to 1. Okay, so the answer of it will be 1, and that is the essence of the probability. Okay, so on the basis of it, what do I have to find out here? That is the question or example here. So let me first find the solution of this example, and let me tell you what is inherent in it. So what is the probability that he will serve at least 5 cars on his next day at work? Okay, so in this example I have to find out the probability that he will service cars, at least 5 cars on the next day. Okay, so the cars should be greater or equal to 5. Okay, or it can be what? It can also be 1 minus probability that he will service cars less than 5. Okay, so how is it possible? I previously told you guys that always the probability of cars greater or equal to 5 plus the probability of cars less than 5, this ultimate sum of it will always be 1, because this is the overall scenario here, because here you can very easily see that the cars greater or equal to 5 are here, while the cars less than 5 are here. Okay, so this is the overall, which is 1. Okay. So having it all the ranges lies here, what we have here, we can see that here this is the same range we have here, which has been graphically illustrated here in these cars. Okay, similarly from it I can also have a formula which is here. Now putting all values here, what we can see that probability of the cars greater or equal to 5 is 1 minus probability of cars less than 5. So these are what? 1 minus probability of the cars less than 5 are which? So these are the probability of the cars equal to what? 4 plus the probability of the cars equal to 3. Okay, so these are the two scenarios which has been mentioned here, and these are the probabilities which I already know. Putting them here, I will get what? This would be 0.19. Okay, and it would be 0.12 here we have here is okay. So it would be 1 minus 0.19, 0.12 is 0.31, which will ultimately give me 1 minus 0.31 is 0.6. Okay. So that is what? That is the solution of the example 2.32. Okay. So as we have seen all the scenarios which has been going on here, I will try to solve the question 2.67 in our upcoming video. So you are expected to grasp all the concepts which are now illustrated in example 2.32. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. So in previous video we have seen the solution of example 2.32. okay, and the answer of it we have got, and on the basis of it we have also seen the limits which are mentioned here, and how can these limits are summed up to 1. Okay, so now on the basis of it, let me solve different parts of question 2.67, and the first part of it is, what is the probability that no more than 4 cars will be served by the mechanic. Okay, so this is part A. Let me write it the solution. Okay, this is the solution of part A, and what do I have to find out? I have to find out that there are no more than 4 cars which are served by the mechanic. So cars are less than or equal to 4. So we can also write it like probability of the cars equal to 4 plus the probability of the cars equal to 3. Okay, which are what? Which are basically mentioned here in these two scenarios, and this is what? These are the number of cars less than 4 equal to 4. Okay, so this is 3, 4. Now putting their values here, what I will get? The probability of cars equal to 4 is 0.19, and the probability of cars equal to 3, that is how much? That is 0.12. Adding them all together, I will get 0.31. Okay, so that is the solution of part A of this question. Okay, similarly for part B, let me write here. For part B, what is the probability that he will service fewer than 8 cars? Okay, so what do I have to do? I have to find the probability that he will service the number of cars which are fewer than 8. Okay, so 8 are basically all of them, so I have to add the probability of 3, 4, 5, 6, 7, all of them all together, so it will be difficult for me. So I can see here that if this is less than 8, I can also have the other part of it, and that is what? That is the probability of cars greater than or equal to 8. Okay, I know that I have already the probability of the events where the cars are greater or equal to 8. So let me put it here, and I will see that this is 0.07, so it will be 0.07. so by adding the probability of only one event, I can have the final results, and it would be 0.93, and that is the probability of the event that the serviced cars will be less than 8 number of cars. Okay, so that is the solution of part B. Similarly, in part C, what is the probability that he will service either 3 or 4 cars? So what is this? He will have to service the number of cars equal to 3 or 4 cars. So or is usually represented by this union, or the number of cars is equal to 4. So there I have. So now here I have to do what? I have to add them together, because now the probability that cars are equal to 3 plus the probability of cars equal to 4. Okay, so these are the two events which are here in this union. Okay, so these are basically the two events. Let me underline them here as well. This is the first one, this is the second one, while this one is now put it here and this one here. Now putting their probabilities, which I already know, this one is here, this one is here. So now let me put them here and I will get one. The probability of it is 0.12 and the probability of force is 0.19, which will ultimately give me 0.31, and that is the probability of the event that he will service either 3 or 4 cars. Okay, so that is the solution of part C, which we have seen here. So we have solved part A, part B, part C on the basis of the conditions given here. So this is the first condition, this is the second, and this is the last one. So if you guys have any question, you can ask me in the comment box. So that's it for today, and I will see you soon. Hello guys, so question 2.68, and the statement it has is interest centers around the nature of an one purchased at a particular department store. It can be either a gas or an electric oven. Consider the decisions made by 6 distinct customers. Okay, so this is the statement, and the part A of it is that suppose that the probability is 0.40 that at most 2 of these individuals purchase an electric oven. Okay, what is the probability that at least 3 purchase the electric oven? So we have here the solution. That is the solution and solution of part A. And here we can see that we have in total how many customers? We have 6 customers, and we know that the probability that individuals are less than or equal to 2 plus the probability that the individuals are greater than or equal to 3. So this is equal to 1. This must be the sum of it must be 1. Why? Because we have here 1, 2, 3, 4, 5, 6. So we have these number of customers, and here we know that the probability is 0.4 that at most 2 of these individual purchase an electric one. So at most here this is what the probability if it is 0.40, while the probability of total of it is 1. So how can we find out this one? Okay, we can find it out by subtracting this one from this one. Okay, and so we would get this one. Okay, so this is the formulation or mathematical formulation of the same diagram which we have shown here. So here the probability that the individuals are greater or equal to 3, that is equal to 1 minus the probability that the individuals are at most 2. Okay, now putting their values, what I will get, this is 0.40 and here I will get 0.60. So that is what, that is the answer of part. Similarly, in order to solve part B of our question, what do we have to see? We have to look at the statement here, and suppose it is known that the probability that all the 6 purchase the electric oven is 0.007, while 0.104 is the probability that all 6 purchase the gas one. Okay, so this is what, this is the probability that all of them will purchase the gas one, while this one is for the electric one. So what is the probability that at least one of each type is purchase. So let me first see what is the probability that a person will either purchase gas oven or electric oven. It would be what? It would be probability of G plus probability of E. Okay, now let me put their values here, and these are given here. So electric oven is 0.007, 0.007, and gas one is 0.104, 0.104. Okay, adding them I will get 0.111. Okay, so this is this one. Now in order to find that what is the probability that at least one of each type is purchased, what do I have to do? I have to subtract this one from 1, so I have to make it like 0.111, and from it what I will get? I will get 0.889, and that is basically the solution of part B. Okay, so that is what? That is the solution of part B. So that's it for today, in which we have seen the solution of question 2.68. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 2.69, and the statement it has is, it is common in many industrial areas to use a filling machine to fill boxes full of product. This occurs in the food industry as well as other areas in which the product is used in the home, for example detergent. These machines are not perfect, and indeed they may be A, fill to specifications, B, underfill, and C, overfill. Okay, so according to these statements we have a given data, okay, which basically lies in three ranges, which may be A, B, C. Okay, we may categorize or classify the overall detergents in the form of A, B, or C, where A is word, A is fill to specifications, so fill to specs. Okay, B is word, underfill, and C is word, D is overfill. Okay, we have these three conditions. Generally, the practice of underfilling is that which one hopes to avoid. Okay, underfilling has to be avoided. So let PB is word, that is 0.001, which is the probability of the underfill, while probability of fill to specs is 0.990. Okay, so that is basically the probability. Let me write it with the help of this black color. So probability of A is word fill to specs is 0.990, which means it's a very good system because the probability of fill to specs is higher, while the probability of the underfill is probability of B is what or how much, that is 0.001, 0.001. So now according to this question, what do we have to find out? We have to find out what? We have to find out A, P of C, probability of the overfill. Okay, so that is not overall, but let me correct it. That is overfill. Okay, we have to find out the probability of the overfill, and that would be how much it would be. In order to find it out, we know it very clearly that in this scenario we have three conditions in such a way that probability of A plus probability of B plus probability of C, this is equal to what? This is equal to 1. Okay, so using this formula, what I can get in order to find P of C, I can have here probability of C is equal to 1 minus probability of the A plus probability of B. Okay, so now putting values here, I will get 1 minus, this is probability is 0.990 plus this is probability of B, that is 0.001. Okay, so now let me move here. here. So probability of C would be 1 minus 0.991, or ultimately I will get here 1 minus 0.999, so I will get here 0.00. Okay, so that is the answer of part A. Okay. Similarly, what is the probability that the machine does not underfill? So now, in order to find the answer of part B, we have to find out the probability that it doesn't underfill. So the probability of underfilling is given, which is PB. So I want to find out the probability of B complement. So it would be 1 minus probability of B, putting values here, 1 minus this is 0.001. okay, so I will get here how much, that would be 0.999, which is quite high, okay, because the system is very efficient. So this is the answer of part B. Similarly, what is the probability that the machine either overfills or underfills? So I have previously told you that wherever I will get this or, there I will have to use the union notation. Okay, so therefore here let me use the condition that the machine either overfills or underfills. So overfill and underfill, these two are given here. So I have to write here probability of B or C or any one of them. So this would be what? It would be probability of B plus probability of, okay, so these two has to be put here. So probability of B is how much? That is 0.001, and probability of C is 0.009, 0.009. Okay, so adding them together, what I will get? I will get here 0.010. Okay, so that is what? That is the answer of part C here. So that's it for today, in which we have seen the solution of three parts of the question 2.69. If you have any question, you are welcome to ask me in the comment. Thank you so much. Welcome back, guys. This is question 2.70, and the statement it has is, consider the situation of exercise 2.69. Suppose 50,000 boxes of detergent are produced per week. Okay, so the given data, let me write it here. So given data here is, okay, so the produced number of boxes per week are how much? These are 50,000, okay, as given here. And suppose also that those underfilled are sent back. If there are any underfilled boxes, those would be sent back with customer requesting reimbursement of the purchase price. Suppose also that the cost of production is known to be $4 per box, while the purchase price is 4.50 per box. Okay, so therefore the profit per box will be how much? The profit per box will be 4.50 minus 4.00, so it would be $0.5. Okay, so the profit I will have here would be $0.5 per box. Okay, so here we can see that. So on the basis of it, what do we have to find out? There are two options. So in part A, we have to find that what is the weekly profit under the condition of no defective boxes. Okay, so here let me solve it. So in solving it, I can very easily see that the number of boxes which are manufactured per week are 50,000, and there is a profit of $0.5 per box. So therefore weekly profit under the condition of no defective boxes will be, weekly profit will be how much? It would be the 50,000 multiplied by 0.5. okay, so it would be 25,000. So that is the answer of part A. Okay, so that is what, that is the answer of part A. Similarly, in part B, it is asking us that what is the loss in profit expected due to underfilling. Okay, so as given in exercise problem 2.69, the probability of the underfilling is how much? You can also see in problem 2.69 that it was basically 0.001. Okay, so as the probability of it is already given, so therefore the total number of boxes which can be underfilled per week can be calculated by 0.001 multiplied by this 50,000. Okay, so now multiplying them together, I will get here 50, and these are the number of boxes which will be underfilled. So if these are the number of boxes which are underfilled, so the amount of the consumption which will be associated with these boxes would be how much? So let me solve it here. So I will have here 50 multiplied by 4.5, which is basically the $4.50 per box. When you have to sell it, that would be here. So calculating it, what I will get here $225. Okay, so that would be what, that is basically the loss which we will have if we will found any underfill items with the probability given here in this scenario, which is here. Okay, so that is the solution of what, this is basically the solution of part B, and this is the expected loss of the item. So that's it for today, in which we have seen that how to find out the weekly profit, and if there is no loss, and similarly how to find out the loss in profit when we will encounter any underfilling in the detergent boxes. So that's it for today, and I will see you with some more stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.71, and the statement it has is, as the situation of exercise 2.69 might suggest, statistical procedures are often used for control of quality. It is industrial quality control. At times, the weight of a product is an important variable to control. Specifications are given for the weight of a certain packaged product, and a package is rejected if it is either too light. Okay, it can be either too light or too heavy. Historical data suggests that 0.95 is the probability that the product meets weight specifications. Okay, so let me write given data here. So given data, according to the given data, that the product can be of normal weight. Okay, or let me write P of n is equal to 0.95 probability of the normal weight. Similarly, weight specification, whereas 0.002 is the probability that the product is too light. Okay, so probability of too light is equal to 0.002. For each single package product, the manufacturer invests $20 in production and the purchase price for the consumer is $25. So on the basis of it, what we can find out, we can find out here the profit for each product, and that would be the $25, 25.00 minus 20.00, and that would be how much? That would be 5.00. Okay, so on the basis of these two items, we have found out the profit in each item. Okay, so on the basis of this data, what do we have to find out? There are three options here, or three parts of this question. In part A, what is the probability that a package chosen randomly from the production line is too heavy? Okay, we have found out that the probability of the normal package is 0.95. The probability of the too lightweight is 0.002, but we don't know the probability of the too heavy package. So therefore, in order to do so, what do we have? If the probability of too heavy is probability of H, okay, so we know that probability of too heavy plus probability of too lightweight plus probability of the normal package, that is always equal to 1. Okay, so let me find out the value of P of H. So P of heavy is, that would be 1 minus probability of the lightweight plus probability of the normal. Okay, now let me put their values here. So 1 minus probability of lightweight is 0.002 and the probability of normal is 0.95. Okay, so we will get 1 minus 0.952. Okay, and subtracting it from 1, I will get 0.048. Okay, so that is what, that is the answer of part A. So that is the answer of part A. Similarly, in order to find the solution of part B, for each 10,000 packages sold, what profit is received by the manufacturer if packages meet weight specification? Okay, so for each package, we have found out the amount of profit which is given here. So now in order to find the total amount of profit for the 10,000 packages, that would be the number of packages which are 10,000 multiplied by the amount of the profit which we can get for one package, that is $5. So on the basis of it, we will get $50,000. So that is basically the amount of the profit for the 10,000 packages. Similarly, now assuming that all defective packages are rejected and rendered worthless, how much is the profit reduced on 10,000 packages due to failure to meet weight specific? So if we are getting 10,000 packages, what is the probability that the packages will be defective? So that would be here. So if I am getting the probability of 0.95 for the normal packages, so for the defective one, the probability would be 1 minus 0.95. So that would be 0.05. Okay, so for the defective one, this is given here. Now in order to find the number of the defective packages from these 10,000 packages, what do we have to do? I have to multiply this 10,000 with the probability of the defective items, and that is 0.05. Okay, so multiplying it, what I will get here, it will be this one, these two will cancel out, and from it I will get here 500. So for the 500 packages, how much cost will I get and how much profit will it has? So let me multiply this 500 with this $25, which is the total cost, which not only includes the actual car but also the profit as well. So therefore it will be 25 multiplied by 500 is, that would be $12,500. Okay, so that is what, that is the cost which will be reduced from this 50,000 if we will get the defective items according to the probability which we have found out here. Okay, so that is basically the solution of part C, in which we have found out the solution of the three parts on the basis of different conditions. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 2.74. And these questions are now related to the conditional probability. So what is the conditional probability? We will get to the point after a while. So let me first read this statement. A class in advanced physics is composed of 10 junior, 30 seniors and 10 graduate students. Okay, so let me write the given data here. So given data is in advanced physics class, there are 10 junior students. Okay, so the junior students are 10 in number. Okay, similarly 30 senior students, we have 30 senior students and 10 graduate students. Okay, so graduate students are 10. So this is the data for the number of students in a class. So the final grade show that 3 of the junior students, 10 of the seniors and 5 of the graduate students receive an A for the course. So let me write the course data here. So here I can write with this black color, and 3 of the juniors, okay, and 10 of the senior, and similarly 5 of the graduate students have received A grade. Okay, so these are the grade A students, these are the total number of students, okay, and these are the symbols I have been using for different cadre of the students. So these are basically the number of students and the number of students who has got A. If a student is chosen at random from this class and is found to have earned A, what is the probability that he or she is a senior? Okay, so let me solve it here. Solution of it is here, and what do we have to find out? I have to find out the probability that he is a senior student given that he has earned grade A. So on the basis of the conditional probability, what do we have? We know the formula that to find out the probability of A given the probability of the event B, it would be the probability of A and B divided by the probability of B. So here, what do we have here? So here A is the probability or the event that a student is senior. Okay. B is the event that he has earned A. Okay, so therefore on the basis of it, what we will have here, we want to find out the probability that he is senior and he has earned A divided by the probability that the student has earned A. Okay. So do we know the probability that a student is senior and he has also earned A? Yes, that is also given here, and that is here. Okay, because now we have the 10 number of students, okay, who are senior and attained A grade divided by the total number of students, which are how much? Which are here 50. Okay, so that is what that is for this one. Okay, so he is also A and also senior student as well. Do we know the probability of earning A? Yes, we have it as well, because here we can see that there are basically 3 plus 10 13 plus 5 18. So we have here 18 students who has attained A grade while the total number of students were 50. So therefore this is the probability of attaining the A grade. Okay, so the probability of the earning A is also given here, and also the probability of attaining A and S is also given here. So let me put these values here and I will see that this will be the solution of this question. So let me use this blue color for it, or let me use this color. So now putting values here, so senior and earned A, that is here. Okay, so it would be 10 divided by 50 divided by the probability that he has earned A, that is 18 by 50. 18 divided by 50, these two will cancel out, and at the end I will get 10 divided by 18 or 5 divided by 9. So that is what, that is the solution of our question which we had to find out. So that is the solution of our question, in which we have seen the application of the conditional probability, that how easy it is to imply it for the given condition and see the results which we had to obtain. Okay, so that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.75, and the statement it has is a random sample of 200 adults. Okay, so the total number of adults are 200, are classified below by sex and their level of education attained. Okay, so this is basically the table which basically corresponds with the sex of the 200 adults and their education level. If a person is picked at random from this group, find the probability that A, the person is a male, given that the person has a secondary education, and similarly part B here as well. But before going to discuss part A and part B here, let me have some probabilities here. So the total number of the male individuals here are 38 plus 28 plus 22. So this is 88. Okay, so the total number of male are 22. Okay, similarly the total number of female are 45 plus 50 is 95 plus 17 is, that is 112. So let me use this color for it. So the total number of female are how much? These are, let me write it here. Okay, so let me use this color and write it here. So the total number of female are 100. And similarly, the probability of female on the basis of this number would be 112, which is the number of the female individual divided by the total number of individuals or total number of adults, which is 200. So therefore, I have to divide it over 200. So therefore, P of F is 112 divided by 200. Similarly, the probability of the male is how much? That would be, sorry, this is not 22 but 38 plus 28 plus 22 is how much? That is 82. So that is basically the 88. Okay, so this is basically, let me remove it and write it from, so it would be 88. Now in order to find the probability of the male, I have to write the number of male individuals divided by the total number of individuals, which are 200. So that would be 88 by 200. Okay. Similarly, on the basis of the education level, what we can do here is that here we will have different levels. So those can be elementary, secondary and college education level. So let me write them here, and choosing this color for the elementary education and adding them male and female together, 45 plus 38, that would be 83. So 83. Okay, and the probability of the elementary education, which would be probability of elementary education would be 83 divided by the 200. Okay, similarly, now using this red color for the secondary education, and now adding 28 plus 70, and here we will get 78. Okay, and the probability of the secondary education here would be the 78 divided by 200. Okay, similarly for the college students, I have to add 22 with 17, and let me use this color for it. This is 22 17, so 22 and 17 is 39. So here the probability of the college education would be, that is P of C, that would be the 39 divided by 200. Okay. So we have found out different probabilities on the basis of this table, and you would also know that how to find out the probabilities of different elements. First of all, what we have done here is that in order to find the probability of the males, we have found out all the sum values here. Then for the female, I have summed all these values. Okay, these are the column wise values, and then divide them over the total number of adults. Similarly, for the education levels, what I have done, I have added all these values on the basis of these rows. Okay, here for the secondary this one, and for the college level this one. Okay. So those were what? Those were different levels which I have made use of here. Okay. So now in order to find the solution here, we have now different probabilities which we have found out. If a person is picked at random from this group, find the probability that A, the person is a male given that the person has a secondary education. Okay. So in this part, this is part A, we have to find the probability that a person is male such that a person has a secondary education, so the education level is secondary. Okay. So by using the conditional probability, what we can write here is that we can write here the probability that a person is male and his education level is secondary divided by the probability that the education level is secondary. Okay. So now let us see that what is the probability, or what are basically the number of the males which has the education level equal to secondary. Do we know that? Yes, that is already known, and this is here given, and this is, we can see that this is the number of males who has the secondary education which has been shown by this entry. So therefore this would be the number of the males who has the secondary education divided by the total number of male, or total number of adults, which are basically 200. Okay. So divided by the probability that the education is secondary. So how can we find it out? The education level which is secondary, let me use this color here, that can be found out by adding the secondary level row here. So this would be 28 plus 50, that is 78. Okay. So the 78 here, 78 divided by the total number of individuals, because I have to write or find the probability here. So I have to write here 200. These two will cancel out, and here I will get 28 divided by 78, or simplifying it, I will get 14 divided by, here it will be 39. Okay. So it will be what? 14 divided by 39, and that is basically the solution of part A here. So this is the solution of part A. Similarly, now solving part B, the person does not have a college degree given that the person is a female. So what do I have to find out? I have to find out that the education level of a person does not have a college degree while the sex is given, and that is female. Okay. So on the basis of the conditional probability, what do I have to write here? I have to write that the probability that the education is not college and the person is female divided by the probability that a person or adult is a female. Okay. So now looking at these values, do I know them that what is the probability that the education level is not college degree while the person is a female? So let me see here that, so here I have to remove this column from it, and also I have to see that what is the probability that the person has what? The person is does not have a college degree while she is a female. So that is what, that would be here. Okay. So this is what we will have, in which the person or the adult is a female and he has or she has the elementary and secondary education. So that would be 45 plus 50, and writing it here 95 divided by 200, because the total number of adults here are 200, divided by the, what is the probability that a person is female? Did I know that? Yes, I have already found it out here. So writing it here 112 divided by 200. Okay, these two will cancel out, and here I will get 95 divided by 112, and that is the solution of part B, which I. Okay. So this is part A and this is part B of our question 2.75. So that's it for today, in which we have solved two tricky parts of a table in which we had to find out the probabilities which are conditioned with some other probabilities. So that's it for today, and I will see you soon.